second Summer Fruit Industry webinar. I acknowledge the traditional owners of country throughout Victoria and recognise their continuing connection to land, water and culture. I pay my respects to the elders past, present and emerging. My name is Mark Hinksman from Agriculture Victoria. I'm responsible for online extension of the project you'll hear about today. This week, we take a look at the supply chain innovation research. And if you missed last week's event, there is a video recording of the webinar on production and ag tech research from the AgVic Smart Farm in Tatura. The research you will hear about today is funded by the Hort Frontiers Asian Markets Fund, part of the Hort Frontiers Strategic Partnership Initiative, developed by Horticulture Innovation with co-investment from many departments and growers. So our speakers today, we have Trevor Ranford, our CEO from Summer Fruit Australia, who will provide a industry update, Summer Fruit industry update. Also, we have Glenn Hale. I just want to say that due to medical reasons, John can't be present today. So Glenn Hale is going to present on both topics. And those topics are impacts of cultivar, stepwise cooling and temperature management on stone fruit quality for export, and deploying smart trackers to monitor stone fruit export in real time. So just at the end of each presentation, if you have any questions, please raise your hand by pressing the hand in the reactions section on your screen, or alternatively, you can write the question in the chat box and I'll read it out on your behalf. And we do a poll for each of these. It's very important. So please fill out the survey before leaving this event today. This provides us with information to improve our webinars and information services. And just to let you know, all presentations are being recorded and will be made available on a Horticulture Industry Network's website. And links to these presentations will be sent via newsletters, both the Profitable Stone Fruit newsletter and the one that Trevor sends from the Summer Fruit Australia. And I'll now hand you over to Trevor Ranford to kick it off.
Good afternoon, everybody, and welcome to this second session on stone fruit research. As Mark indicated, we would normally historically do a roadshow, but because of COVID lockdowns and COVID in general, that hasn't been possible. So we've got these two presentations, and I'd like to thank Mark and his team for setting the program up and running them over the previous week and this week. And the important aspect that Mark has highlighted is that all of these presentations are being recorded and are available. Many of you were on the session last week, so I'm really not going to go over a lot of the previous slides. What I'd like to do is just touch on a few things because it's far more important that we spend the time looking at the research. But just from the point of view of an update from Summer Fruit Australia Limited, we communicate regularly with our members. We have a whole range of activities across R&D, marketing, market access, market intelligence, export opportunities, and right through to running R&D activities like a showcase we did in May and these sorts of events. Just a quick update from the point of view of last year's export summary. We export over 20,000, nearly 21,000 tonnes, and that, given the circumstances of the season and COVID, it was a very good result for the industry. And the last three seasons have been in that area between 21 and 23,500 tonnes. So we've certainly held our own in that regard. Some of the industry challenges are there on the slide. I'm not going to talk too much about them specifically, but they're the activities that the industry is dealing with on what is a day-to-day basis. In relation to our research and development, we have a number of projects that we're involved in, and this particular project and the supply chain is SF 17006. What is important to notice is that we've got a number of projects that are funded from additional pools of money, and those in Victoria may well have seen the released by the Minister, I think yesterday, and that highlighted a particular project, which is the MRL Toolkit, which is a project being developed and run by Cherry Growers of Australia with table grapes and summer fruit. And there will be an announcement on a stone fruit project by the Minister in coming days. Just from a point of view of program update, of recent times, we've updated our MRL data, and we have an extensive database and spreadsheet of MRLs for Australia, Codex, and the export countries. As I said, we're working with the cherry growers and table grape on another MRL project, and the end result, hopefully before the season starts, will be an MRL app for the stone fruit industry. The industry's appointed a new trade development manager, a lady by the name of Olivia Tate, based in Victoria. She's on board and settling in very well. You may have heard that IFAM, which is the freight assistance mechanism, has been extended by the federal government through to middle of next year, which is very much welcome for the stone fruit industry to assist in exports for the coming season. And the new ag visa has been announced and is due to be in place by September, the end of September. But the reality is it's not going to solve all of our problems. It's just another piece of the Labor jigsaw puzzle. As I said, there will be a formal announcement by the Minister on a new stone fruit trade for market project, which has been funded by the Victorian government. And it's a program and a project between Summer Fruit Australia and Ag Victoria. So we will make people aware of that going forward. CEDA, which is our Summer Fruit Export Development Alliance, has got a new structure in place and a range of working groups covering those sorts of areas. And also CEDA is progressing what's called a Majestic Pearl concept, but it's going to be a new marketing brand specifically focused at this point in China, but hopefully it will expand out from there, and you will hear more of that with a industry launch in early October. The registration process for China, Taiwan and Thailand is completed, and audits have been done by DOR. We had a project meeting for one of these projects, 17006, so we're planning how that process will go forward. And the industry is working with Austrade to undertake a number of presentations, country presentations. And excuse me, the day is very much about dealing with exotic pests and diseases. Sustainability is the new topic, along with climate change, working on benchmarking activities and biosecurity. So that gives you a brief update on where the industry's activities are. As Mark has highlighted, the presentation from last week is now available in one of those links. And it covers off on a range of other slides that exist within this presentation, but I won't go through at this point in time. So that's just a brief overview of where the industry is at. And again, thanks to Mark and the team. And we'll now move into the more important aspects, and that's discussing and reviewing the R&D work that's going on.
My name's Glenn Hale. I work for Agriculture Victoria. and I'll be presenting some of the results from the R&D trials that we've been working on in the service supply chains for the past few years. I guess the medical sub for John Leprestri today. And I'll be presenting on the impact of cultivar stepwise cooling and temperature management of stone fruit quality during exports. I'll just briefly cover some research that we've done on cultivar performance and the potential for storage disorders. I'll talk about stepwise cooling to reduce some of these storage disorders, the impacts of temperature management during export. We have developed a calculator that can help predict fruit shelf life storage. And at the end, I'll present something on where we're going from here. And just like to acknowledge the AgVic team at AgriBio, John, Janine, Christine, and Marty. So 4 cultivars that we've been looking at, nectarine ones, early season, mid-season, and some late season ones. Cultivars perform differently under different storage conditions, and we've done some storage trials here at 2 degrees and at 8 degrees. And we've got changes in firmness here on the y-axis, and you can see some variations in cultivar performance there, with September bright minimal changes over roughly 3 to 4 weeks storage. And then say for 2 week storage, you can see a bit of a drop off in June sweet. And then at higher temperatures, which could be linked to, say, air freight temperatures, obviously the firmness decreases a lot more due to the higher temperature. But you can see once again, September bright perform reasonably well. And that's after 12 days storage. All these cultivars were harvested at what we call commercial maturity, somewhere between 5 and 6.5 for these cultivars that we looked at. So just as a general rule of thumb, as we go through the season, storage potential generally increases due to reduced softening. And however, there is an increasing susceptibility to some of these storage disorders. In terms of cultivars and types, yellow flesh peach generally stores better than, say, a white flesh peach, and similarly for nectarines, yellow flesh store better than white flesh. However, there's some decreasing susceptibility to storage disorders as we go along this chain. And I guess it can be linked to, genetic differences within fruit types, tree age, and also orchard climate. Yes. So over the last 4 years, we have developed this matrix of storage performance that a lot of growers and exporters have appreciated. We have on the left side the different types of stone fruit, the seasonality, their cultivar names, maximum storage duration based on for sea freight at 2 degrees. We've included the low, moderate and high risks for storage disorders here and what those limiting factors might be. Most of them are chilling injury. However, fruit softening due to reducing firmness is in there as well. And we have, as a guide, included maximum harvest maturities based on DA values and also on firmness values. And I'd just like to highlight Flavour Pearl here, 0.7 on the DA and 7 kilos for firmness for maximum harvest firmness there. And I'll talk a little bit about that in the next presentation. So storage disorders are a problem. They do affect eating quality, and signs of them include flesh browning, dry or rubbery texture, abnormal or inconsistent ripening, and obviously low juice. And it's all highly cultivar dependent. And as far as I know, many cultivars that are susceptible aren't necessarily, many cultivars, especially the newer ones, are susceptible. And I guess that's why we've done some of this storage trials to determine which ones are better than others. Most breeding programs, however, don't generally test for storage performance or storage disorders. And the standard practice in industry is to cool fruit to as low as possible, close to 0 degrees, as soon as possible after harvest. And I guess to help extend sea freight duration, there's a minimum time for some of these disinfestation protocols of roughly 18 to 21 days at less than 3 degrees. So cultivars need to store for at least that long. The usual trip from some of the temperature monitoring work that I've been doing could last anywhere between 25 and up to 5 weeks, just for the sea freight leg. So cultivars need to perform or to store for this kind of period of time, especially for exports. So we have done some stepwise cooling. We've been monitoring the performance for Majestic Pearl, Nectarine and Polar Queen Peach. We've done some trials on these, and this is the protocols that we've been following. So commercial harvest, we've been, this is the commercial harvest here. Early, we've been using we get a mixture of the spread of fruit based on DA value, these ones being early fruit or unripe. The majority of the fruit that we've harvested fall into this commercial harvest, and that's the ones we'll be using in these trials. And these riper fruit are too soft, I guess, for long-term storage or for export, so we discarded those. We did separate a third of the fruit into different stepwise cooling. So some of the fruit went in was immediately cooled down to 2 degrees straight after harvest. We did cool a third of the fruit down to 12 degrees and another third of the fruit we cooled down to 18 degrees. We did, and we held that at for 48 hours at those temperatures. We separated the fruit into trays. Then we assigned, so we've got the 3 pre-cooling treatments there. And then we assigned these trays into 4 different cool rooms for long-term storage. And we removed a portion of the fruit weekly for up to 6 weeks. And then we did shelf life assessments on these straight out of storage, and we did ripen some for 3 days and for 5 days, and I'll show you some of the results there. So all fruit was preconditioned down to these 3 different temperatures within 7 hours of harvest, and we did hold them there for 2 days at those conditions. And all the fruit that we used in these trials were of the same maturity, which was the commercial maturity. And I guess that helps to eliminate any more variables. So for some of the results for Majestic Pearl, storage for 6 weeks at 2 degrees. On the left, we have ripening after 3 days and then ripening after 5 days at 18 degrees. You can see there's significantly more flesh browning in the fruit that was cooled down to the lower temperature compared to the higher temperatures at 12 and 18 degrees. And slightly more incidence and severity after 5 days ripening there on the right. So looking at it, I guess scientifically, there was no flesh browning, we saw in the first 3 weeks. However, we saw the initial browning we saw was in the fruit that was cooled down to low temperatures, the commercial fruit after 4 weeks. And then we've got 5 weeks here and 6 weeks flesh browning on the left. We have, the commercial fruit here. And then the next lot here is the 12 degrees and then the 18 degrees. This is straight out of harvest. And then the 3 and the 5 days ripening at 18 degrees. And we can see after 6 weeks storage, the fruit that was cooled down to 2 degrees showed significantly more flesh browning than the fruit that was cooled down to 12 degrees. And the fruit that was at 18 degrees showed a lot less flesh browning. If we're to implement this stepwise cooling into commercial export conditions, for stepwise cooling for 48 hours down to 10 and 18 degrees, you'd cool the fruit down for that long, for 48 hours. Then immediately, if you're packing it for domestic or for sea freight, and then cooling it down and then storing it on pallets before exporting it. If there was a delay in packing, then you could potentially follow this line, cooling fruit down to 2 degrees, storing it and then packing it later on for export. The graph on the right is for air freight. It's not something we would recommend you go out and do straight away. Might be worth trialling on a small consignment, and we'll be doing that again next season. Similar sort of process, cooling fruit down to 10 or 18 degrees for 48 hours, storing it, and then immediately packing it for export. And then and cooling it down to 10 degrees here. And if you were fumigating it, then the fumigation process doesn't have to warm up the fruit as long as if it was cooled down to a lower temperature, like 2 degrees early on. And then the export process here. Looking at stone fruit temperature management and shelf life predictions, we've developed some models based on temperature and time experiments. We've done extensive air and sea freight simulation trials at AgriBio. We've done it mainly on unripe and commercially ripe fruit. We've been looking at flesh firmness or softening as the quality indicator. And these models that we've been developing can be used with real-time data, and I'll show you an example of that in a minute. The models do have an accuracy of plus or minus up to 3 days. And if we've applied them to these export stages, 5 of them, where we've assumed harvest to freight forwarder, air or sea freight consignments, importer storage, distribution and retailing, and then consumer ripening at, say, 18 degrees or room temperature. Some of the time and temperature experiments we've done for Majestic Pearl, we've been storing fruit at several different temperatures, and you can see flesh firmness here, the decrease in firmness as the temperatures increase, and we've stored them fruit for different periods of time. And this is we use some of these results in the calculator just for when there's changes in storage times or temperatures during the export process. We've been able to add these values into that calculator to make it, I guess, more robust. I'll just try and use or show you an example of this impact of temperature and storage duration on fruit softening. This one is based on white flesh nectarine. And I guess typical growers or exporters might have questions like, what does the impact of time and also temperature have on flesh firmness throughout the export process, or what is the impact of high quality during air freight on fruit quality? And this model has been based on the work that we've done over 4 and 5 week storage periods, and it also assumes that there's no storage disorders or flesh browning, because that can sort of complicate the model a lot more. Okay, if we're assuming a harvest value of 8 kilos, we'll be able to put in different storage times, and we'll see the effect of the temperature has on the firmness here. If I do a air freight simulation first, say at 8 degrees here, if I put in, say, a realistic time of harvest to freight forwarder of, say, 5 days, and air freight time of, say, 2 days here, nothing's really changed in the firmness here. I guess because it's early on in the process and the temperatures are relatively low. If the temperature is a lot more extreme, you'd be seeing effects here already. And let's assume that the importer stores it for, say, 4 days here. We'll see what effect. You can see firmness decreasing here. And then, say, 3 days for retail and distribution. You can see the firmness dropping off here, and the consumer here, I guess, would potentially have the fruit at roughly 6 kilos firmness. If we assume, if we go and try and do a sea freight simulation, let's say 24 days for sea freight, and see what effect that, and I should change this to 3, say 2 degrees for sea freight. You'll see that there's a small drop off in firmness between the freight forwarders and the importer receiving the fruit. And then if the importer was to store it for, say, 2 days, we'll see what effect that has. The firmness will be roughly 4.5. And then, say, for distribution and retailing, if it was, say, 1 day, yeah, not sure what's going on there. All right. I might refer to John's presentation, that we'll have that in a lot better detail than what I've explained it there. I just jump back into the presentation. I'll just go on to the next slide. If the importer was to use this calculator, and if they wanted to see how long shelf life was remaining on the fruit, if they received the fruit at, say, 4 kilograms, and we change some of these parameters to, say, storage temperature 3, that's all right. If 5 days from harvest to freight forwarder, or sea freight, let's say 24 days here. So if we go back here, 5 days storage from harvest to freight forwarder, 24 days for sea freight, then the importer would have the fruit at roughly 2 point. The shelf life on the fruit will be roughly 2.6 days. Some of the outcomes from the research that we've done, the simulation trials can inform cultivar storage potential under commercial and export conditions. Stepwise cooling appears to significantly reduce potential for storage disorders. The real impact of quality due to temperature and storage time can be understood using these shelf life and storage models. Good temperature management is obviously always important, but the impacts of temperature on quality depend on cultivar and storage performance. More temperature work is required from harvest through to freight forwarder, and also during the importer storage and at retail, to help make these models a bit more robust. Where to from here? Stone fruit. We have a stone fruit traceability project for the next 2 years that's just started. It's funded by Agriculture Victoria. We will do some more commercial testing of the stepwise cooling. So we will be looking for some volunteers for that. Further sea freight simulations that we'll be doing at AgriBio. We're following fruit on the tree prior to harvest, and just to see what orchard impacts have on the effect of irrigation and fruit position, what effects they have on storage disorders. We'll also look at the effect of orchard climate and location on these storage disorders. I guess looking at different regions, say between Cobram and Swan Hill. And we have some models based on Majestic Pearl and September Bright so far that we'll want to continue to validate. And also we'll potentially look at modified atmosphere packaging to extend the storage life for the long sea freight journeys that we're seeing at the moment. And also developing this online dashboard for stone fruit shelf life models. A lot more information is available on the Hidden website. And I know John has recorded this presentation earlier. So I would refer to that for more information. My next presentation I'd like to present is on deploying smart trackers to monitor stone fruit exports in real time. As Mark's mentioned, it's part of the Service Supply Chains Project AM 1502. And there's a photo of the fruit market in Shanghai early on last year. For this presentation, I'd like to run through a summary of what we've been doing, and then show you some real-time loggers, show you a dashboard that Queensland DAF have been developing and we've been trialling. I'll go through some results for both air and sea freight. I'll show you some data updates and alerts from the real-time loggers, and some results for the outturn and the retail assessments. Next steps, some more info and the acknowledgements. So in the past 4 years for this project, we've looked at probably over 100 air and sea freight consignments for stone fruit and table grapes, mainly to Asian countries. And there was a few apples that went to Europe, where we were just checking the performance of the dashboard. We have conducted several outturn and retail assessments, mainly in China, in Shanghai, and a couple in Guangzhou as well. And we did another outturn assessment through a third party in Malaysia, the middle of this year on table grapes. So the main goals of the Service Supply Chains project is to identify the weak spots as part of this temperature monitoring work, help streamline the export process, and to ultimately improve the quality and the consistency of the fruit from Victoria. So the real-time loggers I'll talk about today are these ones here. Emerson, Frigga, Sensitech I've been using, just started trialing some Tive ones and about to get some Escavox ones. They all have SIM cards in them. So they should be treated, I guess, a lot like a mobile phone in that they do need to connect to the network to get data. I've listed several benefits of using these real-time loggers. And the first one here is that they've got sensors in them to monitor location, temperature, and light. Some of them have shock sensors or vibration, and it's in real time, provided it is connected to a network, I guess. So live data and reports can be visible remotely through these logger dashboards or mobile apps. So basically the data from these loggers is at your fingertips and you can potentially view it any time of the day or night. Another benefit of these loggers is that if you can set up temperature and location alerts via email and SMS, you can see where the consignments with these loggers are in, or if there's any issues, and potentially doing something about it before the consignment reaches the final destination. Of the loggers that are available, some are, I think, potentially better for land or for sea or even for air, because some of the loggers have a flight mode function, obviously, for air. There's two types of flight mode functions. One is automatic, the Emerson, and the Emerson logger has a geofence that's built in to the logger. So when the logger goes through this geofence around airports, it will automatically go into flight mode. As a backup, there is an accelerometer in the Emerson and also in the Tive logger, so that when the plane takes off, the logger will pick up rapid changes in speed and height and automatically go into flight mode. And then obviously when the plane lands, it picks up the changes again and it will disable the flight mode function. There's a manual function on some loggers like this Frigga one. If you're in their dashboard, if you go to device settings, you can type in where you want flight mode to be activated. Say at Melbourne Airport, it'll automatically put a 5K ring around the airport. So when the logger passes into that zone, it'll go into flight mode. You can set up alerts here. And then the only other thing that you need to do is include the time of the flight that the logger needs to be in flight mode for. So that's a manual version compared to the other loggers that are automatic. These loggers that I'm talking about today are single-use loggers. So unlike USB loggers, you're not reliant on anyone else to collect the loggers and send information back. You have information at your fingertips. So you're not relying on anyone else to collect them. They're relatively cost effective at about $75 each. They do go over $100 depending on which loggers you have. There's ones with probes that can measure, say, pulp temperature as well as ambient temperature, or even, say, on a long cable, you can measure different positions within a sea freight container using the same logger. And I think another benefit of these real-time loggers is that all links will be more accountable because you can set up these alerts and you can see what's happening pretty much all along the export process. Talking of airline approvals, there's 3 loggers here. The Tive logger has the most approvals, over 50. The Emerson one has approvals for over 30. And the Escavox logger has relatively new, has approvals for roughly 8. I guess it's not so much the number of airlines that have approval, but it's more about which airlines you would be using for your export of fruit. That is important. The other thing to note with flight mode is the loggers continually record during the flight, but they don't actually send the data until they come out of flight mode. So that'll be at the other end. Pretty easy to use or to activate these loggers. The Emerson one, you just pull a white tab out to start it. These other ones have buttons on the front or the back, which you just need to push and hold for a few seconds until you see LEDs flash and some beeping noises, which indicates that they're active. It's important to start these loggers 1 to 2 hours before deploying them in consignments, because they do need to connect to the mobile network. And it's also handy to start them in an open area so that they can connect before going into a container, or you could potentially run the risk of not getting any information until the container reaches the importer overseas. It's important to record the serial number, and on this Frigga logger there is a activation or additional code on the back that needs to be entered into the dashboard for you to access the information. And I guess making a note of where you position these loggers within a consignment. Where to place them, the logger companies recommend placing them on top of the last pallet in the truck, or say a sea freight container. That's where signal is best. You can put them in the middle or in other positions, but the signal may be compromised. It'll still record, but you won't get info until the other end, which may be too late. We've been putting the loggers inside the carton at the top here at the back, just to measure the ambient temperatures around the fruit more than what's actually in the container. And I'll show you an example of that later on. If we look at the dashboard that QDEF have been developing, and we've been trialling with these consignments this past few years, if we log in, this is what you would see. It's a user-friendly dashboard compared to some of the other logger ones. It is quite basic, but it will show you the time and the temperatures for your consignments that you've loaded. This is the landing page. We have a dashboard here. We've got 40 or 50 loggers that are archived. We can show you how to manage a device and shipments. There is a shelf life calculator linked on this dashboard. It's mainly for mangoes at the moment, and I guess we'll be hoping to add stone fruit and potentially other crops in here as well. And then on the left here is the default settings. If we go across here, you can see a consignment ID, what fruit you might have in the consignment, the origin and the destination, which logger. Interesting thing about this dashboard is we have the API for several of these loggers. So rather than logging into individual logger dashboards, we can just stream most of them into this one. And it's just a matter of selecting which logger here. Here's the logger name and some other information. This is just an example here that I put in yesterday. So there's no records, but we can link QR codes to this logger and to the consignment. So I guess for traceability, that could be quite important. If we go to manage, there's in setting up a logger, it's a two-step process, and I'll just quickly go through that now. So if we click on manage device here, this is what we would see. If you add logger here, it'll come up with another screen where you can put, you type in which logger it is, the code, and some other information here, submit, and then if that's successful, you can go to, sorry, that should be manage shipment there. And then we go into setting up the logger, add shipment, and then it'll open up another screen where we can input a lot of the information about the logger and the consignment that it's going in. So you can type in emails here for notifications. Here's the type of logger again, the code, what position the logger would be placed in a consignment, and any other additional information, more specifically what sort of fruit, and the variety, origin, destination. This is just an example. Departure date. We're getting in early for this one later in the year. If we scroll down further, there's room for more information. Then here we can type in temperature alert settings. You can type in whatever temperatures you want here. And if the logger exceeds these, you can get an email. Also, you can set up location alerts. I'll put this one at, say, 2 kilometers. And then it's a matter of where you want these location alerts. So I've just put in an example of this nectarine consignment going to Hong Kong. Just typed in Coode Island, where the ports are in Melbourne. If you know which way the sea freight container is going around Australia, you can, if it's stopping at Brisbane, you can put an alert there. And I've put an alert here for when it arrives in Hong Kong, and you can see it here, and then it's got the 2K radius around there. And my tip is to just add an extra final location that the logger won't go to, so that it doesn't automatically stop when it gets to the destination that you actually want it to go to. And then if you hit submit here, be successful, and then it'll come up on the dashboard with the consignment there that you'll be monitoring. If we go back to dashboard and we look at, say, a real example of one that we've done earlier in the year, I think we'll look at this one here, shipment 24. And this is what we would see on the dashboard. So you've got some shipment details here with the logger information, the position, the status of when it arrived or when it left certain locations. You would see temperature graph here. The red lines are the thresholds that we've set. If you were to hover over any part of the graph, you'll see the logger number and also the date, the time, and the temperature. I've added just these locations in here just for ease of use. And then down the left-hand side, you've got a shipment summary of when it started, where it was last logged, roughly the time that the trip took, and certain parameters for temperatures down the left here. And then you can see a map of where it actually went. And these green dots would be updates of where the logger connected to mobile networks. Looking at a delayed cooling trial. This one's on table grapes that we did earlier in the year, but I thought it'd just be interesting to look at this logger. We used one with a probe on it. So we had a we had the logger inside the carton and the probe outside the carton in a sea freight consignment. The graph here at the top and the bottom and the map on the right is what you would see on the dashboard of these loggers. And then these two orange images down the bottom here on the right is what you would see, the same information that what you would see on a mobile app. The red line is the temperature thresholds we've set. You can see this one's taken roughly 35 days to go from Mildura to KL in Malaysia. And you can see some nice updates here on the map around the coast of Western Australia, and then through Indonesia and up to Singapore and Malaysia. The top graph here is if you click on this icon. The second graph is if this graph here is if you to click on that one. This was the logger in the carton, so you can see it's nice and smooth. This is the probe that was outside the carton, and I guess it's picking up air movement within the sea freight container. And it's just interesting to see that it fluctuates obviously a lot more than what is inside the carton. With the app here, it's just to see the data, you have to click on all and then toggle these little buttons on to be able to see it on the app. So very quick information, readily available. Here's an air freight consignment of another table grape ones that I've just put in here. It was irradiated at Stereotech. It was just an initial trial after Vietnam approved irradiation for grapes. You can see majority of the time the fruit was kept at the freight forwarder. I guess they had some issues with flights, so they've trucked it up to Sydney here, and then it's gone straight to Hanoi in Vietnam. And it's not uncommon for the air freight temperatures to increase to above 10 degrees. And I've seen that in other fruits like cherries as well. Talking about updates of these loggers, I mentioned that the signal may be compromised depending on where the loggers are. This one's updated a couple of times around the coast, and then there's been no updates until the loggers got to Singapore and then headed up to Thailand. This one I think was a great consignment that went to Thailand. I'll have to double check that, but yeah, there's no updates in the middle section here. And then this slide here is another one showing lots of good updates around the coast. I guess it depends where the container is on the ship. Potentially if it's on the near side to land, well then there's more chance that it'll update to the mobile towers as it goes around. It's had some good updates through Malaysia, through Singapore, through the Suez Canal. This was actual Apple consignment that went to, or was heading for the UK. Here it's past Greece, and the actual logger has run out of battery here in Italy, and that was after 49 days. So unfortunately the exporter forgot to tell me that it was in the consignment, and I wasn't able to change the settings on when the logger recorded or when it reported data. So like a mobile phone, they've got the battery life is limited until it needs recharging, or you can extend that battery life by just reducing the frequency of updates and recordings. Interestingly, this consignment spent 10 plus days in Singapore, and there's been some slight temperature spikes there. Just one benefit of using these real-time loggers, I guess, is another consignment that was heading off to Europe last year. the ship was docked at Fremantle. I received an alert for temperature increasing. I contacted the exporter, who then contacted the shipping company, who then went and had a look at the container and sorted out the issue. And then you can see the temperatures decreasing back down here. So that was a good outcome, or else who knows what condition this fruit would have been if it had to spend another 4 weeks on its journey to the UK. Just looking at an outturn assessment that I conducted in Shanghai last year. Put the logger in at the freight forwarder here. A couple of the loggers. Got a probe in this one that measured pulp temperature. Conducted an initial quality assessment here. Is the fruit being unloaded in Shanghai? And then there's the fruit there that I took back to the hotel room to do a ripening trial on. If we look at some of the data from that, here we have fruit firmness, which is the blue bars. If I just highlight this here, this was the initial firmness, which was 7.5 kilos. It was 0.74 on the DA, which I mentioned earlier in the storage performance of those cultivars. Not much change in firmness between the initial and the sea freight journey. This is where I collected the fruit, and then I ripened it in my hotel for several days at roughly 18 degrees, and you can see the firmness doesn't really decrease at all. And I think it's because the initial firmness was pretty high, plus also the time of the journey and this period for shelf life trial is really pushing the life of the stone fruit. So just shows that there's inconsistencies in ripening and also the quality potentially if it's harvested a little bit high, and also the length of the journey. The eating quality here in the yellow, two we've got here, 1 is very poor, 3 average, 5 is very good. So ideally you would like to see this yellow line increasing. Unfortunately on this occasion it wasn't, and it's just to do with the inconsistent ripening of this nectarine on this just in this example. Whilst in Shanghai, I purchased some other stone fruit from retail, and just like to show the variability in the quality that is available overseas. Probably not the same cultivar, but similar nectarines. 4 different retail outlets, big variation in fruit weight. And also in the sugars. And if we look at the firmness here, you can see these fruit here are relatively high, high firmness, and this one here is a lower firmness. Just keep in mind, consumers like fruit quality to be around the 1.5 to 2.5 kilos firmness. And when I tasted the fruit, because this one was a little bit lower in firmness, it tasted the best, and it also had higher sugars, whereas these other fruit were high in firmness and low in sugars, so they didn't taste very nice. That's just my palate, I guess. Maybe different to what Asians prefer. Where to from here? Continue some temperature monitoring work on farm, looking at trying to get some more data between harvest and packing, and also at the other end for importer to retail, and that'll help make some of those shelf life predictors and a bit more robust, I guess. And also develop a list of, we're trying to develop a list of independent surveyors. Andrew McNish from QDAF's looking at this. based on what we're seeing in the markets and exports, it's a little bit uncertain. So potentially we can use these surveyors to assess the quality of fruit that's arriving in these markets. Obviously, we can't travel there to see it ourselves. Streamlining the export supply chain, trying to reduce the time that it's taking for some of the fruit to arrive in markets will help with the quality. Also looking at harvest maturities and preconditioning to reduce storage disorders and to increase the shelf life. And I know there's a few logger companies that are working with shipping lines to tap into their satellites so that when these real-time loggers can't access mobile networks, they can still send information to users. So that would be quite handy to be able to track temperatures for the entire journey. And we're also developing the dashboard and tweaking the shelf life predictor for stone fruit and potentially for other crops like total grapes as well. More information, there's a few industry articles out there in the vine and also across borders, and there's a lot more information on the HIN website that Mark has already mentioned. And then I think that's about it. I'd just like to acknowledge these funders and other participants as well.